I don't want to shock you, but your mouth is covered in spit right now. And that's not the worst of it. A whole bunch of your internal organs are positively coated in mucus. There's a layer of earwax lining your ear canals, and your skin could ooze sweat at any time. And don't get me started with the urine in your bladder and the poop in your large intestine. It's kind of funny to think of it this way, right? Like, all those substances are disgusting on their own, but the fact that they're in our bodies is totally normal. That's where they come from. They're there for a reason. But the moment that earwax coats a Q-tip or snot shoots into a tissue, it's no longer in the category of our precious bodily fluids and is officially something disgusting. What's up with that? Well, it probably won't surprise you that scientists think our disgust reaction mostly comes down to avoiding disease. A lot of these things carry pathogens, and it's a good idea to stay away from them, especially if we don't know who they came from. It's the same reason you're grossed out by rotting meat or spoiled milk. If it can make you sick, your body throws up a warning flare, and you nope the heck out of there. But what about your own fluids? Well, technically, they're not great for you either. A lot of them exist to block or filter or otherwise get rid of invaders like environmental pollutants or dangerous pathogens. So if you get all up close and personal with the stuff your body purposely got rid of, you risk adding that bad stuff back into your body. Your body's like, dude, I got rid of that for a reason. So yeah, our taboos about bodily fluids are legit. Avoiding them helps keep us from getting sick. But that doesn't mean that these substances are all bad. They do really important things in our bodies. And some of those things are downright surprising. So today, we're going to celebrate our gross, smelly, sticky, oozing, moist, drippy bodily fluids. We'll bust some myths you might remember from childhood and learn why your grossest excretions could save someone's life. I'm Ashley Hamer, and this is Taboo Science, a podcast that answers the questions you're not allowed to ask. To begin this tour through our internal gunk, we need some basic definitions.
Generally, we say that secretions are substances that are carried within your body. It's produced and then transported to another part of your body. So a hormone, for example, a gland inside your body secretes a hormone and it goes to some other part of your body. An excretion, on the other hand, is usually defined as something that is leaving your body. And so obviously poop and pee would be considered excretions. Also sweat and tears would be obvious excretions where the body is making something and then it's leaving the body. And then I also mentioned earwax being sort of like an in-between on that because it's often called a secretion. Your ears are secreting the earwax, but the earwax also eventually leaves your body. It also comes out of your ears eventually. My name is Erika Engelhaupt, and I'm a science writer and editor, and I've written a new book called Gory Details, published by National Geographic Books.
Our bodily fluids have fascinated humans since before we even, knew what they were.
Going way back in medicine, whether you look at, the ancient Greeks and Romans, or you look at traditional Chinese medicine, wherever you look, you find that a lot of our medicine has been based around bodily fluids for thousands of years. The Greeks and Romans had the idea of the humors, and a lot of that was based on body fluids. I mean, we had black bile, yellow bile, blood, and phlegm were considered, these like basic substances that fuel our bodies.
Obviously, medical science has advanced since the days of the four humors, but it's still weird to think about how ancient physicians came up with something like black bile. I mean, I don't know about you, but if black stuff ever comes out of me, that would be a sign that something is seriously wrong. Now, bile is a real substance that's made by the liver, and it's kind of a greenish yellow color. So where the heck did black bile come from? Back in the 1920s, a Swedish physician named Robin Ferris was watching blood separate in a test tube when he realized it. The four humors were probably what blood separates into when you leave it alone. I mean, here's the deal. There's a dark red or black layer of clotted blood that settles at the bottom, which may have been what they called black bile. There's a layer of bright red blood cells above that, which was probably what they called blood. Above that was a whitish layer that could be mistaken for phlegm, and the whole thing was surrounded by a yellowish fluid, the plasma, that ancient scientists may have called yellow bile. That means that the only one of the humors that they named accurately was blood.
The idea that body fluids are crucial to our health and well-being goes way, way back. We just have kind of different ideas about them now. I think we've become actually way more squeamish about body fluids than throughout most of human history, where we were doing bloodletting because it was an imbalance of the body fluids. That idea goes way back. And the same kind of thing, like they believed that if you had too much black bile, it would make you melancholic or depressed. And if you had too much yellow bile, it would make you feverish. And so, we've had all of these ideas about our body fluids being important to our health and needing to be in some sort of balance. And while we no longer think that the humors are, crucial to our health, we still have the idea, and we're still learning about what all of our body fluids and secretions and excretions do for us. And I think that it's really actually been kind of understudied, probably because we're so squeamish and grossed out by body fluids. But it turns out that wherever you look, whether you're looking at earwax or saliva or even feces, that all of these things are really intimately tied up with our health, and they can have good effects and bad effects. But they're all very important to how our bodies function.
That's right. Even earwax is important. It's not just there to tempt us to ignore the warnings on the box of Q-tips. The technical term for earwax is cerumen, and this sticky, waxy stuff is really kind of magical. Not only does it condition and protect the skin of the ear canal, it also keeps invaders out. It does that both physically, by trapping dust and dirt in its waxy clutches, and chemically. Earwax has both antibacterial and antifungal properties. But did you appreciate that? No. After all it's done for you, all you want to do is get rid of it.
I like to say that our ears are sort of like a self-cleaning oven, and the earwax is their easy off. Like the earwax is actually like catching dirt and debris and bringing it out of the ears. So eventually, if you let it do its own thing, the earwax will kind of crumble and come out of your ears on its own. And of course, you can feel free to clean the part of your ears that you can see with cotton swabs and stuff. But of course, most of us don't. And that that goes way back. I mean, earwax has this whole history of being something that we look at mostly as a problem, something that we have to get rid of. And so I found out that there were creative ways of digging out earwax going back to 1800s. There was a doctor, Alfred Hind, who talked about his invention of an iron wire that you would heat on one end and flatten and then twist. And he reported this in the Journal of the American Medical Association, or JAMA, as like a great earwax removal device. And it looked horrible. I mean, it looked so painful. And people are still inventing things like that. I found an invention from 2011 where someone patented an earwax removal device, and it had 24 different kinds of variations of it. Basically a stick covered in all sorts of bumps and bristles, and they just looked so menacing. Like one of them was like a screw-like thing that you would grind the wax out of an ear canal. That just seems like so dangerous. It's such a bad idea. But anyway, we have this whole history of trying to get the wax out of our ears. But actually, most of the time when you're sticking something in your ear to try to get the wax out, you're just pushing it in further, because the earwax is only made in the outer third of your ear canal. And so it's already heading out. By sticking things in your ear canal, you're probably actually just pushing it in further. And so I don't know why we hate earwax so much, but but we seem to have been battling it for a really long time.
Something else weird about earwax? Your earwax and my earwax may be nothing alike.
Looking at the genetics of earwax, turns out that different groups of people have different kinds of earwax. So if you are, for example, European or African, then you normally have the kind of yellow sticky earwax that that I have as a member of those groups. And that earwax is also got compounds in it that smell bad. And so that like sticky yellow smelly earwax, that's a particular genetic trait. And people from East Asia or Native Americans, they have a difference in their gene that controls earwax production. And so they actually have like dry, flaky, more whitish colored earwax, and it doesn't smell bad. And so it's just us, Europeans and African descent people who have that yellow, sticky, smelly earwax.
You can even use earwax to screen for disease.
Scientists are starting to find ways that you can actually look for different compounds in that, the same way that you might look for different compounds in urine to diagnose disease. Like, we do pee tests to check your blood sugar levels and see if you have diabetes, but the same kinds of things can be in earwax. And so, earwax can be analyzed to detect things like hepatitis and some cancers, and even look for exposures to toxic chemicals the same way that you would look in urine for those things. So it's really, who knew that earwax would be so useful and interesting? But mostly people just don't think about it. And so there hasn't been a ton of research.
Next stop on this disgusting magic school bus tour of our excretions, spit. This drippy, bubbly fluid is more than just the lube that helps the meatloaf go down. To start with, saliva isn't just one thing. You have 3 pairs of salivary glands that produce different kinds of spit. The parotid gland in the part of your cheek closest to your upper rear molars, it makes a super watery kind of spit. The sublingual glands beneath your tongue produce a thicker, more mucousy spit. And the submaxillary glands, below and behind the sublingual glands, produce a mix of the two. The different types are excreted for different reasons, and it's all, obviously, out of your control. Your autonomic nervous system is in the driver's seat for this one. And all of these varieties of spit do a lot more than you'd think.
Yeah, saliva is another one that turns out to be really important. I mean, we just think of saliva as, spit as something that keeps our mouths comfortable and maybe helps us chewing our food, or, it starts pre-digesting some of our food. But it actually does a lot more than that. It holds a lot of different substances that, just like earwax I was talking about, can also give an early warning of disease, whether it's, detecting viruses in your saliva or even detecting cystic fibrosis, which turns out that it elevates the levels of calcium and sodium in saliva. So it's doing a lot of things besides just lubricating our food. It's also playing a really important role in our sense of taste because it helps flavor molecules reach our taste buds and actually covers our tongues in compounds that help maintain our sense of taste by promoting the turnover of cells on our tongues and in our taste buds. And so really, without saliva, your food wouldn't taste the same, or maybe you wouldn't be able to taste it at all. So it's another one of those overlooked, unsung heroes of our body, another thing that we make that we don't think much about.
But when it comes to gross bodily fluids, snot is the darling of the medical world.
One of the little factoids that I found out while I was doing research on secretions and excretions was that, nasal secretions actually turned up a lot more often in the scientific literature than earwax did. Like earwax was kind of like the most understudied. You don't see a whole lot about it. Snot or nasal secretions show up more just because we're more familiar with that as being like a sign of illness. And, we know that there are obviously, like, if we have a viral infection, if you sneeze, your nasal secretions can, spread the virus, things like that.
The idea of infection made me wonder, why does snot sometimes turn green? Growing up, my mom always considered that to be a sign of a sinus infection, and she'd whisk us to the doctor in response. But at some point, I heard that was a myth. So anyway, what better time than now to get to the bottom of it? Mucus is usually clear. But if a virus invades your sinuses, your body will start making extra mucus to clear out the intruders. At first, it'll be clear, but as your body kills more microbes over the next couple days, the mucus will turn white. When a lot of white blood cells take up the fight against the infection, they tend to die in battle and get washed out with the rest of the mucus. That's when it starts to turn yellow or green. Green mucus isn't a sign that you need an antibiotic, and if it's a viral infection, that wouldn't help anyway. But if it lasts for more than 12 days or so, it is a good idea to call a doctor. But even the mucus you don't see is doing you good.
We probably don't appreciate enough just what that mucus layer in our nose is doing for us. Because similar to the saliva in our mouth, keeping that moisture in our nose, that also is helping our sense of smell, allowing molecules to get into our body through that mucous membrane and be picked up as smells, or to potentially infect us. As we've learned with COVID-19, the main way that people are getting it is by breathing in and having the virus enter their nose, and it's leaving other people's body in their breath in those little fine aerosol droplets that we're putting out as we breathe and talk. And so we don't think about that mucus layer in our noses very often, but there's a lot going on in it. There's a lot of our immune system that's focused on antibodies and immune system function at that first line of attack in our noses. So that's why with COVID, there's a lot of focus on what we inhale and on our immune system and whether the virus makes it through that first line of attack of our immune system, which is in our noses and in our snot, even if we don't really appreciate that.
Next stop on the Excretion Express, sweat. Remember how you have different types of salivary glands that make different types of spit? Same goes for your sweat glands. You've got two types. Eccrine sweat glands are located all over your body and produce watery, odorless sweat to cool you down. Apocrine sweat glands are in your armpits, groin area, and weirdly, your nipples. And they produce a thicker, protein-rich sweat. That sweat also comes out odorless, but it's a favorite food of certain skin bacteria that produce that familiar BO aroma as a byproduct. If there's one fact you know about sweating, it's probably that it helps remove toxins from your body. And that fact is murky at best.
A lot of us have been to a gym or a spa or something like that, and there are like these sweat detox therapies you can do, or there are special infrared heat saunas that you can go into that promise this idea of detoxing your body and sweating out toxins. And it's an appealing idea, right? Because it seems like when you sweat, you know, of course, it gets smelly and it seems like there's gross stuff in the sweat. So it kind of makes sense intuitively that maybe when you sweat more, you'd be filtering out toxins from your body. Of course, what those toxins are is usually left pretty vague. I think people have no idea really what toxins they're trying to sweat out. But usually when we talk about toxins, we're talking about those kinds of chemicals in the environment that we're exposed to, right? So, you know, maybe things that leach out of plastic like BPA, or metals that are in the environment, or pesticides that we would pick up from our food. And a lot of those kinds of things, it turns out, are really not carried in sweat very well. A lot of what we call persistent organic pollutants, those things like pesticides, for example, that we would get from our food, those would be things that we would want to get out of our bodies. But those kinds of pollutants tend to be soluble in fat and not very soluble in water. So it's like how oil and water don't mix. You know, some things will dissolve well in water, some things will dissolve well in fats. And it makes sense when you think about it that sweat, which is, you know, more than 95% water, it is not going to be a very good way of dissolving and carrying those kinds of fat-soluble compounds out of your body. So just logically, it doesn't necessarily make a lot of sense that a lot of toxins would be coming out of your body through sweat. But there's always some kind of little grain of truth, right, that gives us these ideas. And there are kind of low levels of some toxins that can be found in sweat, in particular things that are more water soluble, like metals, for example. Now, if you had lead poisoning, you really wouldn't want to rely on sweat to get the lead out of your body, even though lead can dissolve somewhat in water and be carried out through sweat. But really, your kidneys and your liver are the main filters for your body. That's what's going to get rid of toxins. And so in general, you're going to pee out toxins, what we think of as toxins, much more so than you're going to sweat them out. And there was a researcher who did take a look at how much you could potentially sweat out. And what he found was that for those kinds of fat-soluble toxins like pesticides, for example, even if you did hours of exercise and sweated very heavily every day, you would not be able to sweat out even 1% of those toxins that you were taking in through your food. So basically, it's just an extremely inefficient way of getting rid of toxins.
In the end, if you really want to get the toxins out, drink water so you pee regularly. Something tells me detoxifying peeing gyms won't be a hit with sauna lovers. Oh well. Speaking of pee, there's a lot more in that golden liquid than toxins. Like urea, a byproduct that comes from the breakdown of protein and is literally named after urine, even though it's in sweat and earwax and a whole bunch of other bodily fluids.
Our urine contains a lot of the nitrogen-containing compounds. Urea is a big one. Basically, everything that comes into our bodies, everything we eat and drink and so forth, all of that is going to get processed by our digestive system, and our kidneys are then going to filter everything. So excretion is a really important bodily function because that's how we filter out all of the waste products and the things that could be harmful for us. And hopefully pass them out of our bodies, right? And so for urine, you're getting a lot of salts out of your body and that urea, a lot of stuff that is like from the breakdown of your food. Like if you eat meat, it has a lot of nitrogen in it, and any excess is basically going to be filtered out through your kidneys and end up in your urine.
But urea isn't what turns urine yellow. That honor goes to a chemical called urobilin, which comes from the breakdown of old red blood cells. It's also bright yellow. The lighter yellow your pee, the more water is in it and the more hydrated you are. Darker yellow pee is a sign you should drink more water, and when your pee is brown, well, your liver or kidneys are probably in distress and you should seek medical attention. Or you've just run a marathon and you know it'll pass. I'm told. But if there's one thing you've probably heard about good old number one, it's that urine is sterile. Well, is it?
So there's this whole myth that urine is sterile and like you could pee on a wound and that would be like a source of clean water to clean a wound, that kind of thing. But that's actually not true. There actually are normally bacteria in your urinary system, just like there are in your gut. And that's one of the things that we're starting to understand is just that our bodies are home to like all of these millions and millions of microorganisms, and they're everywhere in our bodies. They're not just in our poop, they're also in our urine, and they're in pretty much every part of our body. Even like our ovaries and testes probably have their own microbiome, and there are bacteria in our brain. They're everywhere. So that's just one of the many things carried in urine that I think people don't necessarily think about. We think of there only being bacteria in our urine if we have a urinary infection, but that's if there's an overgrowth. There's usually some bacteria in your urine too. I talked to a researcher named Evan Hill at Loyola University of Chicago who actually did research looking at what lives in our pee. And she thinks that this urban legend probably started in the 1950s when there was an epidemiologist named Edward Cass, and he was looking for a way to diagnose urinary tract infections. And so he developed the midstream urine test. That's the test that you do when you go to the doctor and you pee in a cup and you try to catch the pee midstream. And he set a cutoff for how many bacteria were in what he considered normal urine. And it was like 100,000 cell clusters on a culture dish for each milliliter of urine. So it's a little bit of an arbitrary number, right? It's just, that's what he would consider normal because it was typical in everyone's urine. And so when they developed that test, they would say that a person tested negative for bacteria in the urine as long as it was less than 100,000 of those colony-forming units. And so the idea that you tested negative led people to probably believe that there were no bacteria in their urine, whereas in reality, it was just that it was less than this arbitrary cutoff. But that gave people the idea that urine was sterile, that it was normal for us to be bacteria-free.
So like if you're a nurse telling people that their urine tested negative for bacteria over and over, of course you'd start to believe that normal urine doesn't contain bacteria. It makes so much sense. But there's one more myth we've got to bust.
Another thing that cropped up in my research is a long-running myth about what happens when you pee in the pool and the idea that parents can put a chemical compound in their pool that's like a urine indicator dye. And I was told about this as a kid, that if you pee in the pool, it will turn bright red and everyone will see it. It will be this cloud of shame around you. And so I was terrified of peeing in the pool and having everyone see it. And so I remember, getting out of the pool, peeling off the bathing suit to go to the bathroom and everything. It was very effective at keeping kids from peeing in the pool. But it's a total urban legend. Parents have made it up. They have used this to their advantage for years. And so I'm kind of busting them like, kids, that's not true. It's not a real thing. And people from pool chemical supply companies say they get asked for it all the time, but it's not a real thing. There is no chemical substance that you can add to a swimming pool that is specific enough to react just with urine and that you can add in high enough levels that it would react and actually be visible and turn a color. The chemistry just doesn't really work out on that. And scientists are not trying to find such a compound if it does exist. So yeah, myth busted on that one. There's no way to tell if someone has peed in your pool.
Oh, I love it. This is what I love about science communication. You get to find out questions that you had when you were like 7.
Right.
Man, I wish I could go back in time and tell little Ashley, it's all a lie. Don't believe what you hear. Pee in the pool. Pee in the pool. We just have one more excretion to visit before we go. You know the one. It's simultaneously the grossest and the most interesting. I'm talking, of course, about poop. And I don't know what I thought before this, but it turns out that scientists don't actually like being around poop all the time. Apparently it's not the most glamorous research subject.
Even researchers don't particularly want to find themselves immersed in body fluids every day. You know, studying the gut microbiome, for example, you know, we have known that bacteria play a major role in health and illness for a very long time. But it's only really recently that we have started to understand the microbiome of our guts and all of the effects it has on our health. And I think that part of that is because who really wanted to study poop samples? You know, that's not that much fun. And researchers, you know, no one really wanted to be the poop researcher. But now we're kind of coming around to where we're understanding more about the helpful role that the fecal microbiome can play. We're starting to finally catch up to the idea of doing fecal transplants. That's one of those kind of like taboo medical procedures. You're basically taking a healthy person's poop and putting it back inside a sick person. And so the idea is that you're going to take those good microbes from the healthy person and put them into the gut of the person who's sick. And it's been shown to be very effective, but it's still, you know, it's not widely used. It hasn't been really FDA approved other than for emergency use when people have C. diff infections, Clostridium difficile, which is, it's often a hospital-acquired infection. Some C. diff is now antibiotic resistant, so it's very difficult to treat. And so if they can't treat it with antibiotics, if it doesn't respond, then you can do a fecal transplant. But you have to literally get one person's poop into another person's colon and lower intestine. So it's one of those things that I think is just so revolting to a lot of people and doctors. You know, like nobody really wanted to go there. And it's only the fact that it's been shown to be so effective that has really kind of pushed that idea to where people even want to try it. And now what's kind of amazing to me is that doctors have had to fight back against people trying to like DIY the fecal transplant, like getting poop from a family member or someone else. Even some doctors have been approached about whether people could use their pets' poop, which is a terrible idea. Don't do it. Don't try to shoot your dog's poop into your own rectum. That's like a terrible idea. They have very different gut bacteria than we do. But even taking another person's feces and trying to do a fecal transplant at home, I mean, it can be done by enema, but there are good microbes and bad microbes, and you don't want to just shoot poop willy-nilly into yourself. That's, the other person could have viruses or bacteria that aren't bothering them, but would bother you. So, certainly plenty of risks. DIY fecal transplants, not recommended. But there are places that are now providing pre-screened feces. This is actually a job that some people can have. If you're a very healthy person with a very healthy gut microbiome, then you might be able to become a poop donor and donate your healthy poop to a stool bank where it can be saved and used for fecal transplants for other people.
See? Excretions are important. They don't only keep us healthy, they could even save a life. Thanks for listening. Taboo Science is written and produced by me, Ashley Hamer. The theme was by Danny Lopatka of DLC Music. Thanks a bunch to Erika Engelhaupt for talking to me. You can find a link to her book, Gory Details: Adventures from the Dark Side of Science, in the show notes. If you liked this episode, I'd love it if you would leave a review on Apple Podcasts, like Kevin251 did. He wrote, "Excellent, professional quality, super fun show. The sometimes cringeworthy topics are carefully researched, and the show is expertly produced and edited, right down to the theme and background music. Ashley is a terrific podcaster. You must listen." Aw, thanks, Kevin. You can follow the show on Twitter and Instagram. Just look for Taboo Science, all one word. Or just visit the website to find it all in one place. That's at tabooscience.show. That's all for now. See you next time.